Hi everyone, it's Dr. Bianchi with a short video going over how to run a correlation analysis in StatCrunch. Now I'm not going to demo the exact problem from the project, but I'm going to show you the same sequence of steps, just using some other variables in the data set so you can see how to run the analysis, how to interpret the output, and how to write up the results in APA format. So let's go ahead and run a simple correlation. Okay, the first question for the correlation assignment just asks you to compute some correlation values for relationships between variables. A correlation is always going to give you an R statistic, okay, an R value, and you should be familiar with the fact that correlations range from -1 all the way to +1. A correlation of -1 is a completely negative relationship. A correlation of 1.0 is a perfectly positive relationship, and a correlation of 0 means the absence of a relationship. Now, we rarely get those extreme values. We usually get somewhere in between, but you should be familiar with how to interpret correlation results in terms of what the number means. Okay, let's go ahead and run a correlation. So correlations are actually under summary stats. We're going to click on correlation. Now let's say that I'm just interested in the correlation between stress, and I'm going to hit control to get the second variable, and health. Okay, is there a relationship? Maybe I predict that people who are more stressed out are going to have worse health. We know stress is not good for the immune system long term. Let's go ahead and see if that hypothesis is supported in this data set. Compute. Now, this is my R value. Okay, the correlation between the stress score and the health score is 0.33. Okay, we'll just round it at the second decimal point. This is a weak positive relationship. Yes, there is a link. It's not extremely strong or consistent, but it is a positive relationship in the moderate range. Okay, let me go ahead and do another one. Stat, summary, correlation. What about stress and anxiety? Compute. Correlation in this data set between stress and anxiety is virtually 0. It's really hard to get a correlation that bad. In this data set, there's basically no relationship between those two variables. Now, the assignment also asks you to compute a correlation matrix. A correlation matrix is essentially the ability to kind of compute a whole bunch of correlations at once and see them all in a matrix or a table that's easy to interpret. So if I click on stats, summary stats, correlation, let's say I want to look at relationships between stress, health, anxiety. I could even bring age into this. And I could see if any of these variables are related. Okay. And what you want to do when you compute correlations is get the p-value, because the p-value is going to tell you if that correlation is statistically significant. What that means is if there is a relationship in this data, can we be confident that that relationship actually exists in the population? So we'll be looking at that p-value to see if it's greater than 0.05 or less than 0.05. So here I'm going to hit compute. This is the correlation matrix. So you're going to want to copy and paste the matrix for the variables I asked you to run into your Word document. And this is how you interpret this. So these are some variables up top here, and then we also have variables here. So the correlation between stress and health is 0.33, and here's the p-value, well above 0.05. So even though we had that sort of weak positive relationship, it's not statistically significant. The p-value is greater than 0.05. We're not confident that this relationship is consistent and would hold up in the population. Here's the relationship between anxiety and stress. Okay, there's that virtual absence of a relationship, and no surprise, the p-value is huge, not significant. Here's the relationship between anxiety and health. Okay, we just match up the two variables, we go over to the cell, okay, and we can see another mild correlation. Okay, this is a -1, an inverse correlation, a -0.33. not statistically significant. The p-value is above 0.05. So that's how you interpret correlations in the matrix. The first value is the R value, and the parentheses are giving you the p-value. In this data set here, there's not one statistically significant correlation. Anxiety and age comes close, 0.08, but it's not close enough. Okay, we fail to reject the null hypothesis. We can't be confident there's a real link in the population. So how would you write this up? Let me just take an example here. Let me just take this one. Okay, I'm just gonna copy and paste this from my own memory into Word, but you will paste the whole matrix. Okay, so I'm gonna go here, and I'm just gonna show you how to write up a correlation assignment. Okay, so we would indicate that R equals 0.33 and P is greater than 0.05, and then we would say a few sentences. Although there was a weak positive relationship between the two variables, it was not statistically significant. You know, we failed to reject the null hypothesis, right? What if we got a significant correlation? R equals 0.85, P is less than 0.05, right? We would say there is a very strong positive relationship between the two variables. The correlation is statistically significant. Okay, so that's what we want to see in the results for the correlation. And just one kind of note on form, all of our statistical lettering is italicized. So once you're done with your assignment, if you really want to polish it up and make it look professional, go through and italicize the statistical letters. There should be a space there. And then you'll be all set. Okay, so make sure to follow the instructions that I've given in the assignment accurately. I basically showed you how to run the analyses, how to interpret them, and how to write them up. Okay, I am gonna end this video. Any questions, just put them up on the discussion board.